Hi, I'm Yaz and I'm an undergraduate student at Bilkent University in Physics 102, Section 1. In this experiment, I will investigate the validity of Kirchhoff's laws when applied to different combinations of electric circuits by changing the value of the resistances to observe how the value of the current varies. I will change the design and the combination of the components of the circuit and observe the behavior of the current to calculate and compare with the theoretical values and determine whether the Kirchhoff's laws are valid or not. For this experiment, I will use the components of an electric circuit to build a circuit and calculate and compare the validity of Kirchhoff's laws. I predict that Kirchhoff's laws will be valid for any combinations of electric circuits such that the sum of the incoming currents at any junction point will be equal to the sum of the outgoings, and the sum of the changes in the voltage around any closed loop will be zero. Also, the current will decrease as the equivalent resistance in a circuit increases. Now, as you can see, we have independent variables, dependent variables, and controlled variables. Materials I will use are constant DC power supply, 4 resistors for each values of resistances, multimeter, and crocodile cables. First, I use the 100 kilo ohm resistors and crocodile cables to combine an electric circuit. Then I set the power supply to 9 volts and then connect the power supply to the circuit with cables in series or in parallels. I used multimeters by looking at both ends of the components I want to measure the current or voltage and recorded the data. I calculated the currents and voltage changes from the given rules and compared them with the actual values I recorded. I repeated the experiment 3 more times from changing the resistance values. First, setting up of the experiment, I combined a circuit as you can see. When I finished my calculations, I recorded my data and you can see the data I obtained in my raw data table. As you can see, these are the experimental values of the currents that passes through the circuit when the values of the resistors change with a constant DC power supply. When looked at these values, it can be seen that Kirchhoff's first law is valid in the junction point in the circuit I designed, since the sum of the currents entering I1 and I2 to the junction point are equal to the current exiting I3, the junction, suggesting an inverse relationship between the increasing values of the resistors and the current. I also measured the voltage drops on the resistors when the current passes to check the validity of the Kirchhoff's loop law. Here below lies the table of the voltage drop. By these measurements and the comparison, the provided data supplies my previous suggestion that there is an inverse relationship between the value of the resistance and the current. For checking the validity of Kirchhoff's loop law, we should apply the rule. And to check whether the measured values satisfy the equation or not, the values are replaced and the equation becomes as follows. As you can see, the total voltage drop in the loop is found as 8.75 plus or minus 0.01 voltage, which is not completely equal to 9 volts. This is the result of the loss that happened during the experiment. The values that are showed in the tables previously are the results of the values that I measured from my experiment, and now the expected values of the currents and voltage drop will be examined with the use of Kirchhoff's laws again to find the theoretical values and to compare them with the actual experimental values that are measured. First of all, to find the relation between the currents flowing in the circuit, I use Kirchhoff's first law as I1 plus I2 equals I3. Then, to find the values of the currents, I applied Kirchhoff's loop rule to the bottom loop, and the loop rule will be as follows. And then substituting the resistance values, the equation becomes this. However, this equation itself is not enough to find the currents, therefore I applied a second loop rule to the upper loop of the circuit. And the second equation is shown here. Simultaneously solving the equations, the currents are found as you can see. And also the voltage drops I calculated as here. Then these calculations are done for all resistance values and the current values, and voltage drop are reached. The results of the calculations lie in the table here. As you can see, these are the expected values of the currents with different values of resistances. And this is the table of the expected values of the voltage drop across the resistors with different values of resistances. As you can see, I have calculated the expected values of the currents flowing in the circuit and the voltage drop across the resistors with several different values of resistances, and then measured the actual results in my experiment to observe the difference between the real values and the expected values. And now I will show the graphs of these results. First one is the graph of the experimental values of the current I1 as a function of different resistor values. When the graphs I showed are examined, it can clearly be seen that for all three currents flowing in the circuit, as the values of the resistors increases, values of the currents decreases. This relation is inversely proportional and linear, such that the best fit line of the graph is linear and it has a negative slope. Now, the theoretical values of the currents by the calculations through Kirchhoff's laws, I will show them here. First graph is the graph of variation of the theoretical values of the currents of I1. These graphs also show a linear and inversely proportional relationship with the values of the resistors and the values of the currents flowing in the circuit. Furthermore, the expected values are similar to actual values which met the expectations. For the conclusion and evaluation, in this investigation, the experiment I conducted has supported the idea that a linear and inversely proportional relation is present between the value of the resistor in the circuit and the values of the currents flowing in the circuit. The best fit lines of the graphs 1 and graph 4 supports this. Throughout the experiment, it is expected that as the value of the resistors increase, the amount of current flowing will decrease. However, as Kirchhoff's rules are used to validate the measurements, it is seen that there is a slight difference in the values from the original value of the power supply, which is 9 volts, and theoretical values of currents. Reason behind both the measurements of currents and voltage deviated because of some errors and different factors. Firstly, the components used such as DC power supply, resistors, and multimeter will face a small amount of power loss because of their internal resistances that turn into other forms such as heat. Also, when one measurement is done, the voltage difference might change 0.2 from time to time, which causes an incorrect reading at that moment. Thus, it is nearly impossible to fully obtain the theoretical values since it is not possible to get 100% efficiency. Furthermore, there might be random errors while doing this experiment. These errors are tried to be decreased by repeating the experiment several more times. Additionally, measuring tools as multimeter may not be precise enough to achieve the theoretical values since they are old and overly used. Also, human readings and sensitivity might have an impact on the difference in the results. Despite all these reasons, the measured values only have an error percentage of 2.4, which is calculated through the previous formula I gave before. Working with more developed and precise measuring tools and repeating the experiment too many times will help decreasing the errors. The experimental values of the currents flowing in the circuits were mostly consistent with my hypothesis, and this experiment conducted gives an answer to the research topic investigating the variation of current using Kirchhoff's laws. This whole investigation showed that as the values of the resistors increase in a circuit, increases the values of the currents flowing in the circuit decreases. Therefore, the Kirchhoff's laws are valid.